problems. I'm going to put problem 3 and problem 4 on the same video because the other ones are already over 10 minutes. So let's do this pretty quickly. Okay, problem 3 is really kind of the same as problem number 1. We're going to find similarity transformations, but basically instead of actually doing it on a graph and doing the transformations, you're pretty much just kind of explaining in words or talking about it. So basically we can see that, hey, we have two corresponding angles here. So we know we have similar triangles. So now we want to describe or find that similarity transformation. So clearly there's probably going to be some sort of dilation going on, right? Taking this one and turning it into this one. These aren't sides aren't the same size, right? They're different sizes, but we know there's probably some kind of scale factor which leads us to a dilation. So we know there's going to be some sort of dilation going on. We might not know what it is, so we can just say, okay, there's some sort, we'll label it K, right? But we know there's some sort of dilation going on. And then we also know they're not in the same spot, right? They're not overlapping each other. So that means we know there has to be some sort of transformation. So there has to be some sort of movement to the right. Move, not more. Move to the right and left, right? Maybe left, right movement, and then there must be some other movement up or down, right? So basically that's kind of what you're doing on similarity transformations. You're just kind of describing it, and you're not actually doing it, right? So you can try this. You actually do have some numbers here that you can kind of play with. So you can kind of compare their sides to each other, right? Which ones are you going to compare to which? So maybe you need to rotate it first. Maybe rotate this or something and see which sides compare to which, and then see if the extended proportion is true or not, right? See if your ratios are the same. Okay, problem number 4. Determine if these two logos are similar or not. So there's no angles to kind of go on. There's no sides to compare. So basically you want to just say, okay, how could you match these up to one another, right? How would I turn this one into this one? Well, if you would move this tip onto this one, right, and then there would just be some type of dilation. So if I just move right, and then I would dilate, right? So that's all I would have to do is dilate after that. Some number, say K, right? So there's probably, these are similar logos because all you have to do is just kind of describe what you're doing. So I'm going to move, not, what's that? R-I-G-H-T, right? Jeez. So then here you're looking at these two. How can you turn this one into this one? What might have to do? Our movements are left, right, up, and down. We can rotate 180 degrees, or we can flip it. You might flip it over the x-axis or flip it over the y-axis. So those are kind of some words that you would use. You would use rotation. You would use move up or down, and move right, and move down and up, move right or left, and then you do some type of dilation. Okay, so those are kind of the words that you use to describe how you're getting this image to this image, and can it be possible, right? So maybe this eye would be sideways, right? So then you can't do that image because they're not going to be the same, because this eye is different. When you rotate it and enlarge it, your eye would be different than this eye or something like that, okay? All right, so that's it for this video. Like I said, pretty short, I guess 4 minutes, but I did 2 problems, so we're good.